Right, hi folks. Say I asked you to draw this graph of y equals 3x plus 2. What probably you'd start to do would be start to think about a table. And you'd choose some values for x. I've just chosen the positive ones here to make it easier, but often we go from -3 to 3 so we can get a fuller picture of what's happening in the negative. But let's just have a look at these for the moment. I've chosen those freely. You can choose whatever you like. So I'm going to say, let's look at this for a start and think about what it means. The y can be found by doing 3 times the x plus the 2. So if the y is 3 times the x plus the 2, 3 times 0 is 0 plus 2 is 2. 3 times 1 is 3, plus 2 is 5. 6 plus 2 is 8. 9 plus 2 is 11. 12 plus 2 is 14. 15 plus 2 is 17. Now that gives me a series of coordinates which I'm going to plot. So I've got 0, 2 is there. 1, 5 is there. 2, 8 is there. 3, 11 is there. 4, 14 is there, and 5, 17 is there. And I should be able to join those up with a nice straight line. And I would always label that y equals 3x plus 2. Now there's a couple of things to think about. First of all, this point here, the y-intercept, and that is 2. Okay, nothing unusual about that. But let's have a look at the gradient. Let me go from here to here. So in order to find the gradient, I need to find the change in y, which I'm going to put as a delta y, like that, Greek capital letter delta. And I'm going to find the change in x, which is delta x. And my values from this graph here, change in x goes from 1 all the way up to 5, so that's 4. And change in y goes from 5 all the way up to 17, so that's 12. So the gradient is delta y over delta x. I'm sure you've come across these deltas in science before. So that's 12 over 4, which is 3. Now, when we look back at what we had originally, which was y equals 3x plus 2, you can see that we've got some things that have crossed over. So this is the gradient, and this is the y-intercept. So we have a general form of the equation which we call y equals mx plus c, and this always stands for the gradient, and this always stands for the y-intercept. And that's sometimes just called the intercept. So if I said to you, find the gradient and y-intercept for, now I said question number 1 was y equals 2x plus 8. You might say the gradient which I can call the letter M because that's universally known, is 2, and you might say C is, which is the intercept, would be 8. Now we may have some questions where there could be some negatives kicking about. So I could say, what about this one? Y equals 3x minus 9. You could say M gradient is 3, and the intercept this time would be minus 9. So that's taking into account that it's minus 9 we've written there, and that's the different thing. And we could have some with fractions or decimals. So y equals 2/3 x minus 1/8. And again you would say M is equal to 2/3 and C is equal to minus 1/8. So really what I wanted to pick up today was the connection between the formula and what you can see on the graph. So this number here always relates to the steepness or the gradient, which is the change in y divided by the change in x, regardless of where you draw that triangle. And one of the ways I always think about gradient is to say, well, if I went 1 along, how many would I go up? I would go 1 along, and I've gone from 5 to 8, that's 3. And again here, 1 along and 3 up. So I say gradient is how many you go up for every 1 along. Okay, so it's a measure of steepness. Obviously if you went 1 along 2 up, that wouldn't be as steep as if you went 1 along 10 up. 1 along 10 up is going to be much steeper than 1 along 2 up. So that's how we measure our steepness of our graph. So gradient always comes as your M, and y-intercept is always your C. It's always where it crosses the y-axis. Okay?